Hi, welcome to everyone's favourite segment, Mailbag. It's been a while and we're going to do it old school behind the camera here. Yes, we've got the trusty knife. Look at that bad boy. Thank you very much, Daniel Nagy from Budapest in Hungary. Hi to all my Hungarian viewers. We don't get many from Hungary, do we? So if you want to send something into the mailbag, send it to Mailbag. Got to put Mailbag on it, otherwise I don't know. And I think I've just ordered something. So Mailbag, PO Box 7949. Balkan Mills, New South Wales. Should be Norwest, actually. They renamed the bloody thing. Norwest, New South Wales, 2153, Australia, not Austria. Let's go. Yeah, that is in the middle. And what do we have? Ta-da, a note. We need to read the note second because I like to be surprised. We have 9 volt. Is that a 9 volt battery? I assume we've got something that needs a 9 volt battery and is very handily provided a 9 volt battery for it. Bonus bubble wrap. Ooh, it looks like the Star Wars crawl. Look at that. Cool. And what do we got? Whoa, this looks cool. We've got, what's in here? Is that like a postcard or? Yeah, it's a photo. It's a photo. Let's have a look before we look at the item. I assume that is Daniel's bench. There you go, Rady's bench. Nice and clean and simple. I like it. It's a lot bigger than I've had in some places, let me tell you. Yeah, terrific. We have a schematic. Look at this. The Mikkel CC2 electronic load. Oh, I guess that's what we've got here. We've got an electronic load. And of course I've done my, there's been tons of people who've done a version of my very crude, simple electronic load over the years. So looks like we've got an LM4040 there, couple of LMC 4682 there. That's a dual jobby. And there's some IFR 1405 transistors there, and he's put those in parallel there. Have they got the same? They got exactly the same drive on each one by the looks of it. They've all got their own individual current sharing resistor there, we've got an old school analog meter up here. Brilliant. And our power circuit, this is a classic reverse polarity protection circuit here. We've got the P-channel MOSFET here, a VP3203. I don't know that off the top of my head, so I don't know the specs for that. Maybe I'll put up a data sheet here. But anyway, we've got a 12 volt Zener diode here and a 10K from gate to ground here. And basically, and this is designed to prevent hooking up the battery the wrong way. It's idiot proof. So if you put it backward, I won't go through the whole theory, but you put it up and put it back, put the battery backwards, the P-channel MOSFET doesn't turn on and your circuit is protected. But if you put it the right way, you'll have a high enough gate source voltage here, which will switch the MOSFET on, no problems whatsoever. The thing I don't understand is though you don't actually need the Zener diode and the resistor here. The Zener diode here is only designed to prevent, like if you had a higher voltage here in your battery than what the maximum VGS voltage of the MOSFET is. So this one, like you've only got 9 volts. So having a 12 volt Zener diode here, I don't think that's doing anything. And you don't need the resistor. So if your battery voltage is less than the rating of the max rating of the MOSFET, then you can just put the gate straight down to ground and Bob's your uncle. And we're just driving a red power LED. I don't know why you had to put it across VREF there to turn on the transistor. It seems, wouldn't you, I'd just whack it across the rail, but maybe you wanted to detect if the VREF has failed, perhaps. Yeah, anyway, and you probably don't need your decoupling cap. So you can do a bit of muntzing here. You can munce the circuit. Pretty sure you can get rid of that. 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 Yeah, more betterer. Anyway, let's have a look at the unit. Oh, let's have a look at this thing. I'm liking the look of this already. Looks like a Bobby Dazzler. And, whoa, look at that. That's a beautiful case. I love those sloped front instrument cases and an old school analog meter. Isn't that beautiful? Daniel actually says in his note that this is an off-the-shelf case, but he's got handmade cutouts and laser engraving on there. And that's just, beautiful. Thing of beauty. A joy forever. Look at that. That is gorgeous. A lot of pride has gone into that. Got a nice 10-turn pot here, no wuckers. It's almost a shame that we've only got the, of course I like the analog meter, but you know, of course you can put a meter in series and actually get the exact current if you're that desperate. But often, you know, like, oh yeah, near enough, just put your, oh, it's not mirrored, so you can't, you know, it's hard to avoid parallax error there. So, you know, if we look at it like that, okay, it might read 0 there, but you look at an angle, it's not 0 anymore. That's parallax error. But yeah, that is just wonderful. What a huge amount of pride's gone into that. I like the flush 9-volt battery connector. External DC too. Beautiful. And these slide out battery holders are neat too. It's just got a spring here to put tension on that. And look, you can't really, well, you sort of can put it in backwards, but different size things there help prevent that. So, that's just fantastic. Look at that. Hook it up to the power supply here. I got 10 volts, and let's set it to 500 milliamps there. Oh, look at that. I got to get the tongue at the right angle. Oh, come on. Oh, the pot just doesn't have the resolution. Come on. Oh, that's going to have to be good enough for Australia. Look at that. That's pretty bang on. Bobby Dazzler. So that'll go up to a maximum of 2 amps, will it? Well, you can go, yeah, 2.084 there. 2 amps. Oh, it's a little bit over. The meter there's not quite, it's a little bit out at full scale. Look at that. Oh, smidge out. But, you know, analog meter for the win, right? Yeah, that's neat. I like it. That is beautiful. I like the effort, the pride and effort that's gone into that. Daniel can be very proud of that. So give Daniel a rating out of 10 below for his little analog meter constant current electronic load. That's just fantastic. The CC2. I wonder what happened to the CC1. Or is that CC2 because it's 2 amps? I think it might be. That's terrific. Well done, Daniel. Oh, I almost forgot the teardown. Look at that. Isn't that it? That is just as gorgeous as the box that it's in. There you go. Got some sill pads there. We've got our dual transistor. Not sure why you went with dual. I'm not going to go through the thermal calcs and everything else. And well, good thing about dual is you've got a bit of redundancy there too. You know, if you blow your tranny, then yeah, no worries. Fused. Beautiful, socketed op amp there, fantastic, little trimmer in there, is that full scale adjust there, and yeah, look at it, beautiful. Let's even put the heat shrink over these. Oh, look at all the heat shrink, a lot of pride's gone into that. Well done. I'm not sure if Daniel sells this. He doesn't have a website, doesn't actually, yeah, I don't think he sells it, but that is gorgeous. He can be proud of that. Once again, rated out of 10 down below. I was just thinking that you don't see many of these cases anymore, these slope-in instrument cases with like the folded metal and stuff like that. You don't see them much anymore. These are traditionally used, like you'll find them in university, you know, engineering school labs and stuff like that, you know, because, you know, they've built their own custom gear and exactly like this, actually. And yeah, these were common, like, you know, folded sheet metal cases where, you know, they're kind of like the standard back in the old days when I was a boy. Yeah, you know, you would have like your folded metal chassis, but this is a gorgeous one with powder coating and everything else. And yeah, but like, it brings a tear to the eye. Next up, we've got one from the Old Dart. Hi to all my viewers in the Old Dart. Thank you very much, Kailesh Sasidharan. I think I've got that right. No, I butchered that one, surely. It has been violated by DHL by the looks of it. Look at that. It's been violated, security checked. So I don't know. Did it get randomly x-rayed and it just showed up? So if we just break their tape, that should get us in, should it not? No. Rather unpleasant. Should have just sliced the entire box. We have a note to me. Let's come to the right place. Ooh, something. What's in here? Ooh. Oh, look. Oh, proto boards. You know we love proto boards. Stamp Basic. Oh, yes, I was clued up on these. These are really cool. These look quite clever. So, what else have we got in here? components and assembled boards. Fragile? Fragile? Really? Fragile? Oh, they got like little pins on them or something? Ooh, look at this. Demo. Okay, we have a working demo here. So we'll power that up in a sec. And we've got AT-Tiny 85, wow, AT-Tiny 85 and a whole bunch of pre-done boards. Yeah, these are very cool. Let's check them out. So this is actually a Kickstarter, and I wasn't able to find the Kickstarter, so I just emailed Kailesh then to see if I can get the link. But anyway, these are designed to replace breadboards, you know, because you just got wires going, all the usual problems with breadboards, right? And the whole idea is that this is called the Stamp, so you got three types, the basic, the regular, and the Pro here, and they're designed to have like interconnects on the bottom here, and I'll have to go through the manual for it, because the manual is actually quite good. But if we have a look at our board here, you can see that we can like solder SMD parts on here. We can like free solder to pads over here. We've got another like SMD over here with like variable width. These are some LEDs soldered up, and we've got a battery. And then on the back, depending on the type you get, they'll have different configuration options here where you can actually just like solder bridge over, like, you know, because here is the unsoldered one, you know, just the blank one, and you can actually solder like route pins in various configurations, route them, you know, ground and positive, and to, you know, various things. So very cool. So you can effectively like sort of program these, like, you know, wire up your breadboard, so to speak, with just like little individual jumpers and stuff like that. And it can get quite complex, the actual configurations that you can actually get on this thing. So yeah, the best thing to do is just have a look at their manual, and they explain that quite nicely. And here's our nice little demo here with our little micro. We've got just a button here, and we can see we can change that. Nice. So we've got like these they're those neo pixely things, are they? I assume that they are. And oh, there we go, look at that. Oh, it's pretty. Isn't that great? So there you go. And that's all done with basically, you know, no dodgy jumper links or anything like that. It's all just like programmed, and you can solder. You know, see, you've got some dropper resistors on the bottom there, and you can just, yeah, solder all these things. And that's a great little demo. Just by like bridging various links and stuff, you can configure your circuit. They're very handy to have in your junk bin. Let me tell you, like I've got like trays full of like these little adapter boards and stuff, and they come in so handy. And these are more than just like little breakout adapter boards. These are like, you know, you can actually easily configure circuits without having to dick around stripping your little, you know, piddly pissant wires on there and trying to, you know, like wire the damn thing up and stuff. So yeah, you can just put little solder blobs, and the castellated edges. And these edges here, they're what's called castellated edges, and they allow you to like just join the boards together, solder them together in an array like that. So that is just a fantastic idea. So unfortunately, I can't find the Kickstarter at the moment, but I will endeavour to link that in if Kailesh gets back to me. So that is great. I reckon that is terrific. Thumbs up, linked down below. And for example, this one here is like got a little AT-Tiny 85 on it. You see how you can solder little itty bitty parts on the top there, and also on the bottom. Look at that. That's great. So let's have a quick look at the manual here, because this is the best way to get an idea of exactly the versatility in this thing. So you can see, you know, all the problems with breadboards, and there's lots. Like, you know, like you get bad springs, bad contacts, dirty contacts. If you pull your radial resistors out of the bandolier tape, you know, they can have glue on the end, and then you stick them in, and the glue just acts as an insulator in your breadboards. And oh man, you can really come a guts with breadboards, but they're still great because I'm old school, you know. But anyway, if you don't like breadboards, here you go. This is how you can like simplify a 555 timer into just this. Like, you know, there's no flying leads anywhere like this. Look, they've got an Arduino, a buck converter switch, LEDs, stepper driver, all that can be reduced to an individual thing like this. So you can see that the we've got the, you know, front side and the back side, but I'll show you the routing stuff here. So you can get different types. You can get the basic, regular, pro, and then you can get the pitch. So they've got all these. You can order it like based on this part number by the looks of it. Very cool. So you can get, SOICs, SOPs, SOTs, VSSOPs, SMDs, QFNs, and, and then junction boards and through-hole boards. And so you've got your castellated edges here. It looks like these are actually pulled back. I didn't look... I was actually going to say that, when you butt them up together, the pins would short, but no, it looks like they've thought about that. It looks like they've routed the bit extra. I have to look under the microscope. Oh, yeah, I can see it. I think it needs to stick out a fraction more, maybe. Geez, but that's the idea, is that, you butt these two boards up, and in theory, they shouldn't short out together, so you've got to actually either solder bridge them across, or as you'll see later, you've got other options. So, that's very cool, but you've got to control your manufacturing process. You've got to watch your PCB manufacturer gets that right, that's actually back like that. So, there's a bit of art in making sure your manufacturer doesn't screw that up on you when you actually, route these things out. So anyway, so you got pin pads, power routing tracks, floating pads, edge pin pads, and all sorts of stuff. And then you got the through hole board, and then you got the junction board. So you can order all these different types of boards, and wait until you see the flexibility here. So here it is, right? So you can route, so you've got this blue one over here, can go over to these pads here, and then the blue can connect to any one of these pins here, and then you should be able to bridge blue to brown here, for example. So you bridge those, and then you can go, so you can get this purple one up here to any of these pins over here. So you've got all this route, and same for the red in this corner, or the green in this corner, or the brown up in that corner. You can route them, in theory, to any one of these pins. So you can use those for power routing, for example. And then you can solder bypass capacitors directly on there to go between power rails and things like that. So you'll have to read the manual in depth for yourself. But look, they've got a 20 pin jobby here, and they've got a similar sort of flexible arrangement going on here. And then this is an example of an LM5164 buck converter here. So you can put this entire buck converter, there it is, entire buck converter on the board like that. Isn't that neat? So there you go. So you can see the solder bridges in there that they've just bridged those over, and it's just terrific flexibility. An entire buck converter on that one little board with no jumper links whatsoever. So you can butt them up on the side like this, so you can butt the different types. So this one has like a 5-volt linear regulator thing, and then it's got like an AT tiny, and as we mentioned, they've got these purpose-built castellated holes. So castellated edges, castellated holes, that's the terminology for when you basically how you design those on a PCB is you just put just a normal pad. There's nothing special. There's no such thing as a castellated hole component kind of thing. Oh, you could technically. Well, that's what they've designed here. So it's a little bit more complicated than that. But if you want to do a basic castellated edge, this one's a bit more advanced, then you just put a hole right on the edge of your PCB and just tell them to route across. So they actually build it as a regular plated through hole, except at the end of the manufacturing process, the routing bit comes along and just shaves off half the hole, and you can be left with little daggy bits that short out and all sorts of things. So there's a bit of art there. So to design that, they would have had to tee this up with the manufacturer to make sure the manufacturer could do exactly what they wanted here. Anyway, so you can get selective. I just realized there's two variants. You can get ones that actually manually put the gap in there, or you can get ones that have no selective connectivity. Oh, wow. Was that up in the part number? That's not up in the part number. How do you select your selective connectivity? I'm not sure. Anyway, I won't go into the details, but it's very cool that you got both types. They've thought about this. So you can put these on pin headers, which then go, if you want to plug it, extend it on your regular breadboard, you can do that, no worries. And then you can route it, manufacture them into cubes like this and right angle stuff like that. I've done lots of that in industry, mount boards into cubes and different angles and all sorts of things like that. Very handy. So, you you can, that's just, a cool way you can solder those together. And then you can use jumper links. These are the selective ones. So you just solder your regular jumper, and then you can just put jumper links in there to select which ones you want. It's great. Or you can use jumper pins. They gave me some jumper pins here. So you can just like solder those directly on if you want a bit more low profile and more permanent kind of thing. And you can put 0 ohm resistors in there, and it's great. And then you can stack them like this, so you can have like soldered like that, like, permanently soldered together, if you want a really low form factor thing. So if you're designing something fairly low form factor, but you don't want to design an entire custom PCB, you can get away with doing something, using these boards to do a reasonably low profile cubey solution or something. Or you can have ones that, you can actually plug them together like this, just selective plug-in. And it looks like they've thought about the width. Like, it looks like it matches the Raspberry Pi width here. Isn't that great? So they've thought about everything. And there's more like color coding of the pads and things like that you can do here. And this is really remarkable. This is the most flexible thing that I think I've ever seen in terms of these Proto boards. Wow. They've, hats off. They've really gone to town here in what you can actually do with these things. Hats off. Progress in electronics. This is great. This is progress. Yes, I like it. So yeah, huge thumbs up to that. I'm very, very impressed. So hopefully you'll get back to me with the Kickstarter link, because as I'm recording this, it's not yet available, but he says he'll hopefully get it, the Kickstarter operational when I release this video, hopefully. So check the link down below. The thought of everything. This is terrific. Although Murphy's Law, you'll get these and it just won't do exactly what you want. There'll be one jumper link. Bloody bastard. Hi to all my viewers in Scotland. You might recognise this guy. Ian Scott Johnston, fellow YouTuber. I'll link him in down below. Definitely check out his channel. It's awesome. And I had to Google what this was. I had to Google Lens it, and Google Lens says this is a Scottish Highland cow. So cool, I guess. Anyway, let's see what Ian. I think I know what this is, because he did clue me up. He was sending something, but let's have a squiz. Oh, these bloody these. If you don't cut every single fiber in these things, they really get stuck. These bloody tapes. Look at them, unbelievable. Jeez, that was an effort. They're pretty strong, those fiber tapes, or whatever you call them. We'll read the note in a sec. But he has sent one of his creations. It's very well packaged. This sucker will be quite useful. Look at this. This is one of his custom creations. This is great. It's specialized bit of kit, if there ever was one. It's a DMM, digital multimeter continuity tester. So it's designed to plug into your multimeter, and then you can set mark space ratios for the pulses that go into your multimeter, and you can see if it beeps. You can test the response time of your multimeter. It doesn't get more specialized than that. Version 1.2 for those playing along at home. And isn't that a nice little build? I like that. And 9-volt battery holder on the bottom. That is sweet as. Let's give it a whirl. So 9-volt battery in. Got a little slide switch on the side here. And DMM continuity tester version 1.2. He's just updated the firmware. So we can set our mark and space ratios in milliseconds here, and our period, and then and it gives you the readout in hertz there. So we can just change that. Look at that. Why doesn't that give 1.1 millisecond? Oh, it can only go up. Oh, no, it can. Is that a key bounce thing? Not sure what's going. Can I get 5? Oh, I adjust. Yeah, I think that might be a key bounce thing. And here's his note, and he's got some example times for various multimeters here. We'll confirm these. And there's his web address for those playing along at home. Definitely, if you're not subscribed to Ian, you definitely should be. So, and we've got a schematic. Beauty. So we've got an Arduino Pro Mini here. We've got just a little LCD module, regulation and switches, and this is all she wrote. Basically, there's our 2 connector interface. We've just got 2 MOSFETs here. So basically, this is the driver, which comes from the micro over here. It's driving just the gate. It's just pulling that down to ground, and then just basically just switching on the MOSFET here, very straight across the terminals. Very simple. So we simply plug it in, and then it's continually shorting these out at a frequency there of 3.9 hertz. So 4 hertz there, and you can see like it's not beeping there, right? So all we do is we just increase this until we can get it to. No, I might have to hold. Yep. There we go. So we got it there, and you can see it's doing. So you 3.7 hertz there, and that's what that is. So, so the BM235 is about 16, reliably at 18 milliseconds. Yeah, let's just say reliably at 20 milliseconds mark there. So that's a total period of 270 milliseconds there. So, can we lower that? We can see that we're getting silly now. We're getting, it's just continuously beeping, but it is actually detecting that. So a space is just, as we increase the space, our frequency is going to go down. So of course, all we really care about here is the mark, which is basically closing the contacts, turning on that MOSFET, shorting out your two input terminals here. So that's the thing that the space and everything is just like how it actually repeats. So it seems to be, about 18 milliseconds reliably there. I mean, that's still, that's more than anyone needs. No one will ever need more than 640K of memory. The BM2257 is way faster. We're talking, 3, 2, let's just say 3 milliseconds there. Whoa. And the fastest bad boy on the block, the BM786, down, We're in microseconds now, hundreds of microseconds. And look at that. That's as low as it goes, and it's still doing it. 10 microseconds. Can't go any lower. And the venerable Fluke 87.5, well, I think we're going to have to go a fair bit quicker than this. Or slower. Sorry. Well, there we go. It's pretty good. Yeah, 0.88. Whoa, 880 microseconds. There you go. It's not too shabby. So thank you very much, Ian. That is a cool bit of like really niche test kit that pretty much only multimeter reviewers or curious individuals would need. So yeah, this is going to be very handy, and it will be my standard bit of kit for testing multimeters going forward. Super duper handy. I don't think Ian, anyway, I'll link in Ian's channel. I don't think he sells them, but I guess if you want to buy it off him, he'll probably make one for you. Anyway, awesome. Thanks, Ian.